Suppose that x is a normal distribution that has a standard deviation of 5, and we know the probability that x is less than 2 is 0.8554. Determine the mean of our x. So we're missing our mean mu. Now what we have is a standard deviation of 5, and then we've just got this probability here. But this probability is going to tell us a lot. 0.8554. Now, mean and standard deviation, we've learned in the lesson, are related as long as you have a value, a little x that you are comparing to, which in this case will be 2, and an associated z-score to this probability. And once you've got those ingredients, mu is x minus z sigma. Okay, you can either memorize that or you can rearrange the usual formula for finding z-scores to suit your needs. So we definitely have the sigma, but what do you mean we've got the x and the z-score? How do I figure them out? Well, let's take a look at what this probability, x less than 2, being 0.8554, is telling us. X is a normal random variable, so it's got a bell curve and it peaks somewhere, and that's what we're trying to find, really. We want to know this mean mu. Okay? Now, we're talking about an area here because our capital X random variable is less than our little x2. So the area that we might draw here is going to be shaded to the left. Okay? Maybe 2 is over here and we get sort of this tiny little area tucked off in the corner. Except our probability is kind of big, isn't it? So it's more likely that 2 is on the other side. We're still going to shade towards the left. Okay? But 2 is probably somewhere over here. Okay? So that's a much bigger area, about 0.8554. That looks good. Now, what would we normally do? What did we learn how to do to calculate probabilities like this in the lesson? Well, what you're supposed to do is change the problem so that you have the same area, but now it's an area under the standard normal bell curve. And instead of 2 here, things get shifted around using this formula, and you get a z-score. But the point is the probability here is still shaded to the left. Probability doesn't switch sides when we do this. And the area is the same. So what we have here is there's this little z associated to our little x of 2, not our capital X random variable. But this little z here gives us the same probability. Okay? So we can just look that up in our chart. So 0.7s, 0.9s, go back a bit, 0.84s, 8.5s, there it is, 8.554 is associated to a z-score of 1.06. So we've got our z-score now. Okay. So we want mu, which is x minus z times sigma, but our x value, the value we are comparing capital X, our normal random variable, to, is 2, minus our z-score of 1.06, times sigma, our standard deviation, which they said in the question was 5. So you multiply those two out, you'll get 2 minus 5.3. 2 minus 5 would be negative 3, and subtract off another 0.3, you'll get negative 3.3. So that must be the mu, the mean of x, our normal random variable here.